Hi everybody, welcome back again. We're going to move on with atomic physics to the uses of radioactivity. We'll look at some good things and some bad things that radioactivity is used for. The first thing I'd like to show you is one of my favourites. I think it's really interesting. It's the use of radioactivity to find out the age of something. In this case, we'll look at radiocarbon dating, which is the use of radioactive carbon to find out when something that was once alive died, or how long ago something died. Above my head, you can see the different forms or isotopes of carbon. This is normal carbon, carbon 12. This is radioactive carbon, carbon 14. These two are isotopes of carbon. This is the radioactive isotope. And this is nitrogen, normal nitrogen. Radioactive carbon is formed from normal nitrogen. I'll explain that process in a minute. And then I don't know if you can see this very well, but above that, you've got one of the most famous dead bodies ever discovered. This is Ötzi the Iceman. He was discovered in the Italian Alps in 1991. He was several thousand years old. 1991, by the way, was the year I left school. You don't need radiocarbon dating, but that was quite a long time ago. And I'm going to give you some work to find out exactly how old this body was, using some data on radioactive carbon dating. Okay, so let me explain the process of how radioactive carbon is formed, or how carbon-14 is formed. It's quite an interesting process. It begins with cosmic rays hitting the atmosphere from space. We don't need to go into this process, but basically it hits gases, particles in the atmosphere, and causes them to spit out neutrons. Those neutrons hit normal nitrogen in the atmosphere, nitrogen 14, and they have enough energy to kick a proton out of the nitrogen 14. So if I just write this little equation, this is normal nitrogen. If normal nitrogen uses a proton, as you can see here, it goes from 14.7 to 14.6. 6 is the proton number of carbon, so therefore you formed radioactive carbon, carbon 14. That radioactive carbon is basically formed into carbon dioxide in the atmosphere. So most of the carbon dioxide in the atmosphere contains carbon 12. A small percentage contains carbon 14. That carbon 14 in the atmosphere in carbon dioxide is taken into plants by the process of photosynthesis. And once it's in the plants, it's eaten by animals. Humans can use plants or animals to either eat or form into other materials. So basically everything around us that contains carbon has a certain percentage of carbon 14. As long as those things are alive, the percentage remains fairly constant, the percentage of carbon 14 to carbon 12, because it's either been replaced by, in this case, photosynthesis, or it's been replaced in your body by the things you eat. As soon as that living thing dies, however, because carbon 14 is radioactive, it's a beta emitter, it starts to decay. And because we know the half-life of carbon 14, we know that after a certain amount of time you'll have lost a certain percentage of carbon 14. After another half-life, half of that again. After another half-life, half of that again, as we've seen before. Okay, so that's the process of how carbon 14 is formed, which you can see here, carbon 14. The next question is how we can use that to find out how old something is. So take, for example, this piece of wood. Once that piece of wood dies, when it's on a tree, the carbon 14 is at equilibrium. The amount in the living thing is fixed. As soon as it dies, because carbon 14 is a beta emitter, it starts to decay, and you start to lose that radioactive carbon. At 0 years, you've got 100% of the carbon 14 you expect. After one half-life, you've got 50%. of the carbon-14 you expect when that thing is alive. The half-life of carbon-14 is 5,730 years. So therefore, it takes 5,730 years to go to 50% of the level of carbon-14 you started with. After another 5,730 years, you have 25% of the level you started with. And after another 5,730 years, you expect 12.5%. That's just half-life to half-life to half-life, as we've seen before. Okay, so then the question is, how can you use that data to find out how old something is? Well, basically, you plot the half-life graph. This is the half-life graph of carbon-14. 0 years, 100% of the expected equilibrium amount of carbon-14. After 5,730 years, 50%, and so on, as we've seen already. Okay, my question for you, you might want to pause after I ask you this question, is, okay, if you've got 40%, let's say, of the carbon-14 you expect in a living thing, how long ago did that thing die? Think about how you would get that value from the graph and what that value might be. Okay, and here's the answer. If we know the level is 40%, obviously this isn't the best graph, and I'm not very good at drawing straight lines, but we find the 40% level, which would be here. Draw a line across with a ruler, which I don't have, obviously. Draw a line down with a straight line. Now I would expect that 40% level to be about 7,200 years on the x-axis. So therefore, if the level of carbon-14 is 40% of the living level of carbon-14, I know that that thing died 4,200 years ago. Okay, now I hope that made sense. I'm going to post this video with some work for you to try, including, which I think is quite interesting, I'll take you a piece of work to discover, without Googling it, find out how long ago Ötzi the Iceman died. Okay, any questions, please email me, let me know. Hopefully see you soon. Stay safe during the quarantine. Look after yourselves and your family. Okay, goodbye.